Okay, so after the last one, I told you we were going to talk about special cases. And so that is what we're going to be looking at now. So there's an actual example here for you on there. And listen to the wording of it. It says, a sign at a ticket booth reads, guests that are under 3 years old and over 62 get free admission. Does this make sense? If not, why or why not? And if it doesn't make sense, how could you change it? So the question here is, can you be under 3 years old and over 52 or 62 at the same time? Can you be under 3 and over 62? Well, hopefully you know that's not possible. And so you can write that down there as your explanation. No, because you cannot be less than 3 and greater than 62 at the same time. So how would we fix this? Well, again, it's just very, very important, the difference in the wording. And so if I change and I put the word or there, and I say guests that are under 3 years old or over 62 years old get free admission, that makes sense. Okay? So again, the word and or are very, very important. So I'm going to rewrite over here again what I told you earlier. Or means we're going to join the graphs. Okay? Join the graphs. So whatever is in one has to be in the other. Okay? And it again is the symbol union. Think about joining them together. The word and means what is in both. What is in both, or what is common to both. Okay, and it is the intersection symbol. So you've got to be sure that you understand those two words. So let's look at some graphs. So the first one says x is less than -3. So I'm going to graph that one. And x is greater than 7. So what this is saying again, the word and, I'm using the word and here. So I want to know, what do these graphs have in common? And hopefully you think they don't have anything in common. No numbers in common. This is going to be a no solution. Okay? Where are you going to see this? If you'll remember, we just did some absolute values on there. So we said that when the absolute value was equal to a negative number, that was a no solution, right? Well, now we're going to say, when will the absolute value be less than, let's say, 0? When will the absolute value be less than 0? Well, that's not going to happen. So when you're doing your inequalities for absolute value and it is less than 0, that's a no solution. Now, it doesn't have to be 0, because I also could say, when is the absolute value less than a -3? Well, again, if it can't be less than 0, it definitely cannot be less than a -3. Okay? So there will be some absolute value equations where you're going to come up with, there is a no solution. When you graph, they will not have anything in common. Okay? And again, we'll talk more about that later. But okay, let's do another one here. So number 2, we have everything greater than a -2. We have everything less than 6. And I want to know what they have in common. Okay? So I can tell they only have this portion here in common. So my answer is going to be an interval. Okay? And so we're going to, when you see this, guys, it is very important then that you rewrite your equation. So even though I draw it this way, my actual answer is just that interval that I just mentioned. So my interval is from here to here. Okay? Interval notation, I'm going to have a bracket at a -2. I'm going to have a 6 and then a parenthesis. Okay? And again, watch this wording, because in a minute it's going to switch. So that word and. So I'm going to have less than 5, less than or equal to 5. Okay? I'm going to have less than or equal to 8. Okay? Now, this one looks different. It doesn't look like either of the first two. So this is kind of our third case scenario. So when you're doing ands, there really is 3 cases you're going to see. You're going to see where they both go in opposite directions. They don't cross at all. It's a no solution. You're going to see where they go in opposite directions and they cross, therefore they have an interval. And now you see them where they go in the same direction. And when I look at this, again, I want to know I want to know what these two graphs have in common. Okay, what do they have in common? Well, hopefully you notice that the only numbers they're going to have in common starts at 5, but goes on in the negative direction. Okay? So again, this is another one of those. We have to rewrite the answer. Okay? So once you get it, you have to rewrite it, because technically the only thing that is a part of the answer is everything less than or equal to 5. Do you see that? So from here, from here on is what they have in common. So I'm actually just going to take off this graph, because all they have in common is from 5 to infinity, negative infinity. Okay? I'm going to take off that line. So that is my answer. Okay? And so my interval notation would say from a negative infinity to 5, bracket. Okay? So those are your 3 scenarios for ands. Now, on number 3, they could both go to the right, but it would still look kind of the same thing. You would still have what they have in common. Okay. Now let's do one more, and then we'll move on to ors. So greater than, negative 4, okay, greater than 2, greater than or equal to 2. So this is the scenario I was telling you, with them going in the opposite, both to the right. Again, what do they have in common? Okay, the only thing they have in common is this part right here. So in this case, I can take off the back, that piece. Okay? How do I write my answer? I'm going to do a bracket at 2, and this one's going to go to positive infinity. Okay? Those are the only 4 cases for ands you will have. Okay? So each time you're going to have to decide which one of those 4 cases do you have as an answer. Okay? Okay, now let's do ors. So ors are going to have the same type of situation, but their answers are going to be different. So let's go to the first one. Less than negative 8, greater than 1. Okay? And now the word here is or, which means, again, this time you're going to just join the graphs. In other words, basically whatever you graph, whatever is graphed is the answer. So with an or, this is your answer, because the question is, it could be less than negative 8, or it could be greater than 1. Kind of go back to our free admission earlier. How do I write it in interval notation again? Well, I'm going from a negative infinity to a negative 8, union from 1 to positive infinity. Okay? Again, that is a very typical or that you see. Okay, let's try another one. We have greater than or equal to a negative 2. We have greater than 7. Okay? Now again, I'm joining the graphs. If you see it graphed, then it's got to be part of your answer. Okay? So I see numbers graphed here. I see numbers graphed there. So my answer is going to be everything from here to the right. So what I do, since it's everything from here to the right, I actually don't even need this piece because it's kind of like it's repeating what I've already said. Okay? And do you see the difference between the and the or when I'm doing those type? So how would I write my answer? Bracket at a -2 to positive infinity. Okay, let's try another one. Less than or equal to 3. Less than or equal to a -9. I didn't quite make my, extend my line on out just a little bit, make it longer. Okay, less than or equal to a -9, which is not even hardly on the graph that they gave us. There we go. Again, it's an or. I'm joining the two graphs. If I see it graphed, it has to be in my answer. Well, I see numbers graphed here. Whoops, I hit the wrong button. That was supposed to be my highlighter. Okay, I see everything, I see numbers graphed here. I see numbers graphed there. So my answer is going to be everything from 3 left, everything less than 3. So what, again, I need to do is come in and take out that graph. I cannot leave it on there. Okay? I'll take out my highlight too. So my answer would be from a -infinity to 1 bracket. Oh, that's not 1. Sorry, that's 3. I don't know where I come up with 1. Okay? Next, we've got everything greater than -1. We've got everything less than 1. And I'm joining these two graphs together. So when I go looking at this, I see numbers graphed here, here, here. There's a bunch of numbers graphed there. Here's numbers. So this is going to be everything. I didn't leave any numbers out when I graphed. Okay? So this answer is actually going to get totally rewritten because it is just all real numbers. Okay? So don't leave those dots down on the number line. It's all real numbers. So my answer would be everything from a -infinity to a positive infinity. Okay? And again, when you think of this, where you're going to see this last one, guys, is if I say, when will the absolute value be greater than 0? When will absolute value be greater than 0? Well, absolute value is always positive, and every positive number is greater than 0. So that would be all real numbers. Okay? So that would be an example. So again, when we go do absolute values, that's what you're going to see. Okay. What are you going to do next? So you're going to go ahead and you're going to solve first. So here's the only difference is these you do have to solve. And then once you're done solving, guys, and you graph, okay, you're going to, may have to look back to what you have here. And your answer will be one of those 8 situations, okay? So this first one's going to be an or, so it's going to look like one of these 4, okay? And you're going to just continue on those.